Previous video we've done the startup sequence of this milling machine in its briefest form. So let's go and have a look a bit deeper into how it actually starts. We come around the back and we turn on the isolator, which puts 415 volts to the coolant pump, the hydraulic pump and the spindle motor during normal running. It also puts power to 3 transformers. This one here is the 61 transformer. It's a 3-phase transformer, as you can see. It has some primary tappings for 420, 440 and 500 volts. Australia's 415, so it's on the 420 primary tapping. Mainly this transformer is for the 150 volt AC supply, 3-phase, to the spindle motor when it's in gear change mode. There's also a single phase tapping at 220 volts AC to power up the coils on the main contactors, on the travel limit switches and on some of the cabinet buttons. It also has a 24 volts AC winding for the work lamp and the cooling fans, and a 3-phase 19 volt AC winding that feeds 2 3-phase 6-diode rectifiers for 2 24 volt DC supplies. One of those supplies goes to the floating backplanes on the Izumi gear change PLC, and the other goes to to the Heidenhain main controller for the inputs and outputs that are floating. The other is for solenoids on the hydraulic unit and for the little gear change motors, of which there are 3 at 24 volts. As an aside, here are the 4 inductors that go into the high current circuit to the servo motors to smooth out the thyristor chopper bit. We come around here in the side door and you can see here transformer 71, which does the servo motor driving, and another smaller transformer which drives both the Izumi PLC that does the gear change and the TNC 155. So there is the Izumi PLC for the gear change, and of course here is the Heidenhain controller. So we can see here again the power interrupted, so we hit the clear button here, clear entry, and now it says 24 volt relay voltage missing. Push the power on button up the top, and now we have it waiting to do finding the reference marks. Now I'll just have a look at the Z-axis. It hunts for the Z-axis first because that's a safe move away from any workpiece or whatever. And here are the cams and limit switch, cam switches for the Z-axis. This one in the back on that bottom face is the maximum that the Z-axis is allowed to travel. This longer cam is a thing for the index. The index mark must lie somewhere along this cam, and it must happen before you hit this guy, the extreme limit, of course. The two must overlap. So it will hunt. If it's not on the cam, it'll hunt towards the cam. It knows which way to go for that. If it's on the cam, it doesn't really know which way to hunt. If it hunts the wrong way and comes across this, it'll reverse and find the index. Depends on where it starts, of course. So we'll just push the program run button here and then have a look at what happens. Found it, right? The next one we'll do is the y-axis. Here we have the index mark. I know it's going to be somewhere here, and here's where the datum for it is. So we'll push the button again. It hunts and finds it. The cams for this guy are on the other side of the Y slide. And here we have the last one, the x-axis, and it will hunt to about that dot there. Okay, so it's found the 3 axes that I've got actually running at the moment, and you can see here now it's ready to run. There's obviously here, the rotary table is the whole main milling bench on this machine. I've got that locked out in software because this vise is a bit long when it's extended back, and it'll hit the slide for the vertical axis. So, and I seldom need to use the rotary table, so I've got that out of service for most of the time. It stays locked. Underneath it there is some hydraulic rams that keep it locked in this position, which is square on to the x-axis, or parallel to the x-axis, sorry. And so unless I need it, in which case it goes on to the servos. The growling sound you can hear in the background now is those 3 of the 4 inductors growling. So the X, Y and Z axes are now being held by the locked servos, and you can hear the current growling through the inductors. So there we go again, that's the whole thing. Finish of this video.